Hello students, welcome back to JCE Connect series of lectures. In this particular lecture, I'll be starting module number 4, that is impact of jet on a curved wings, and another part of this module is turbines, and that too impulse turbine. So here turbines, in this module the turbines will be of hydraulic turbines. So let us start. The first part of this module will be the impact of jet on a curved wings. So what do you mean by impact of jet on a curved wings? So before talking about the curved wings, so let me tell about something impact of jet. So impact of jet means when a liquid is flowing through a pipe. Suppose this is the pipe. When a liquid is flowing through this pipe, a nozzle, suppose a nozzle is fitted at the end of the pipe like this. This is the nozzle which is fitted at the end of the pipe just to increase the velocity of the liquid. This is the water flowing, this is the liquid flowing in this pipe, and as the cross-sectional area get reduces at the end, the velocity of flow will get increases here. Just to increase the velocity of liquid, a nozzle is been fitted here. When the liquid comes out from the nozzle is in the form of a jet. When it comes out from the nozzle, it will be in the form of jet. And if a plate, suppose a plate like this, if this is a plate, if a plate or a vane, it is also called as a vane, is placed in the path of the liquid jet. Suppose this plate or the vane is placed in the path of the jet, then this jet will exert a force on the plate. This jet will exert a force on the jet, and this is what we call as an impact of jet. That is, the force exerted by the liquid jet on the plate is known as impact of jet. The force exerted by the liquid of jet on the plate is known as impact of jet. So it will be having a huge kinetic energy because of reduction in the cross-sectional area at the end of the pipe. The pressure energy get converted into kinetic energy here, because it will be having a pressure energy here and it will get converted into kinetic energy. When it comes in the form of jet, if anything come across the jet or its or in its path, it will exert a force on the plate, and that force what we call as a impact of jet. So that force will be calculating by using the impulse momentum principle. That concept will be using in this particular chapter here. So this is very important, and where it will be using this concept, that is impact of jet on a curved wings. So you might have heard hydroelectric power stations, so where the turbines will be using to generate the electricity. So in hydroelectric generating stations, a jet of water is made to impinge on the vanes. A jet of water is made to impinge on the vanes. So here I'll show you that picture. So you can see here in this figure, you can see where this is the power station. You can see this is the power station where the turbine is mounted here, and the water is feeding from the reservoir into the turbine station. So here the dam is been constructed across the reservoir, and the water is made to flow into a large diameter pipes, and these are called as a penstocks. And through the penstock the water is made to flow into the pipe, and then at the end of the penstock a nozzle is been fitted. As I earlier said, a nozzle is been using just to increase the kinetic energy of the water, and when the water comes out of the nozzle, it will come in the form of jet, and that will be hitting the blades of the turbines. Then the turbine starts rotating. So that is in hydroelectric generating stations, a jet of water is being made to impinge on the vanes of the turbines, and when it impinges on the vanes of the turbines, so that jet get deflected by certain angle. During this process, what happens, a force is exerted by the jet on the vane. So a force is being exerting by the jet on the vane, and that causes the rotation of the turbine. This mechanical energy is further converted into uh, electric energy. The force exerted by the jet on the vanes, moving or stationary, can be determined by using or by applying the impulse momentum equations. So where this concept of impact of jet is been using just in uh, case of hydraulic turbines and all, where the turbines are running by making use of the power of water. There this impact of jet concept will be using. Okay, I hope you understood this one. So here first we'll be starting the impact of jet on a curved vanes. So here the vanes mounting on the this is the turbine, that is the impeller of the turbine. This is the shaft. The vanes will be like this, or the plates like this. Okay, these are called as curved vanes. Okay, so here jet of water is coming out of the nozzle, which is hitting the blades or the vanes like this. It will be hitting the blades like this. So where the moment it hits the blades, then this will moving forward. Then again the next blade will come and stand before the jet. Again it also gets the force, then it also moves. Then again the next blade will come and stand before the jet. This will continue. Then the rotation of impeller will takes place. This impeller is coupled with the shaft get rotates, then the shaft is get coupled with the generator, and the generator get on, hence the production of electricity. So to do these things, a force of jet will be impinging on the vanes. This force we need to analyze. This force we have to analyze by using impulse momentum principle. Impulse momentum principle. We have to use impulse momentum principle to analyze this force. Okay. So you will be studying various cases here, curved vanes. So various cases means the fixed case, also moving blades. So as I said, when a liquid is flowing through a pipe, a nozzle is being fitted at the end of the pipe to increase the velocity of the flow of liquid. Then the liquid comes out from the nozzle is in the form of jet, and if a plate or vane is mounted or placed in the path of the jet of liquid, then it will exert a force on the plate. This force exerted by the liquid jet on the plate is known as impact of jet, and it can be determined depending upon whether the plate is flat, it could be flat, or means this plate could be like this flat, or it could be curved like this. It could be flat or a curved, or sometimes this flat plate could be a stationary or moving. This is also the stationary or moving. So but in this particular chapter we'll be studying only the curved vanes. So impact of jet on a curved vanes, and after that then we'll be analyzing the force by using the impulse momentum principle. Then uh, coming to the turbines, that is hydraulic turbines, the machines which uses the power of water for the generation of electricity, and those are being called as a hydraulic machines. And there also we will be studying that impulse turbine. So about uh, in this impulse turbine, so you will be studying general layout of hydroelectric power plant, how the hydroelectric power plant will be laid, then the heads and efficiencies of the turbines, then the Pelton wheel. Impulse turbine means the Pelton wheel. About the Pelton wheel turbine you will be studying here in its components, that Pelton wheel components, then working principles and the velocity triangles, then how to calculate maximum power efficiency, then working proportions. So these all things you will be studying in this turbines, that is impulse turbines. So I hope you understood this basics here. Okay, so next part of this lecture I'll be starting some more basics uh, about impact of jet, that is a fundamental concept. So we'll discuss in the next part of this lecture. Thank you.